Okay, good afternoon, everyone. My name is Eugene McManus. I'm with Nucor Steel and Nucor Rebar Fabrication. Lyall, you want to introduce yourself?
Yep, Lyall Hadden, right up there.
Yeah, we only have one slide, so Phil took all of my time on that. But anyway, what we were going to present for you today is it's a modular off-site solution which we've been working on over the last 12 plus months. We brought this over to the North American market from Europe. A company out of Ireland, Midland Steel, have been doing this for the past several years. We came upon them through Intel. They did a project in Dublin several years ago. Intel was quite impressed with the way they did the project, and they suggested we get together with Midland, and we've been doing that now for over 12 months. So the project we're going to talk about today is one of our own projects. So Nucor Steel, we're actively building structures around the country. We're currently building a mill in West Virginia. It's quite a sizable project. It's almost $2 billion in expenditure. A large amount of concrete, heavy industrial project. So what we're going to sort of show is a small foundation structure. There's a bag house structure in one of the mill sections. There was two of these structures. So what we were trying to do here is take sort of a before and after, a traditional versus what we could do in a modular example. It's about 11,000 square feet, 1,000 cubic yards of concrete. Altogether is about 136 tons of material. You know, the major conversion here is we went from just traditional grade material to weldable material, because the product, as opposed to being tied in a traditional manner, is welded, and you'll see some of that as we present forward. And then the key metric here to pay attention to is the traditional placement on the example we did, took 125 man hours, which is about 13 days for the 10-man crew. And with the alternative, which was the modular solution, we achieved that in 4 days with a 5-man crew. So much like the gentleman from Seco was saying, there's a challenge in a lot of the structures that we do, where we have a lot of people on the job site, and this is enabling us to do a lot more with a lot less and help with the schedule timing as well. This is the structure here. I know the drawing itself is a little hard to see, but it's about 150 feet by 80 feet is the general dimension. The concrete shape there on your right gives you a little bit more appreciation. It's very unsymmetrical. Again, this solution is very adaptable, very scalable, but we thought this would be a generous sort of suggestion because it does show the flexibility of it. There's just the model representation. Again, various thickenings, various plinths, etc. around the structure. So the way we go about this, and again to sort of address the collaboration conversation, is we like to bring this to willing engineers and contractors early, because we can help achieve a lot of schedule efficiency and a lot of schedule accuracy if we're brought in early. We like to break it down with the modeling. Modeling is a very big part of the solution. We're breaking it down into layers as opposed to 2D type representation. And the key fundamentals here are like the B1 layers, the B2, T2, and then the T1 layers, all which sort of come together to sort of bring a sort of a finished solution. This is more of a model rendering example of how it would come together in a sort of a simple representation. So I'll let this run. It's just a couple of seconds. As you can see, the B1 layer goes down, and then you're constructing the B2T layers together. And then you're closing it off with a T1 layer. And I guess if you can sort of imagine this coming to your job site in this fashion, it helps alleviate a lot of that stick assembly that goes on today in the traditional assembly. This again is a time-lapse simulation of that, just to give a little bit more appreciation of the process. This is how we actually work at this speed. Or we could call it the Benny Hill clip, if anyone remembers Benny Hill. So, just to jump ahead a bit here, the process works around taking a project, slab flat work, which is very much traditionally done in pieces, is where we focus right now, because nobody's really offering a modular type solution. And when we break this down, we would usually break it down into the layers that it's going to arrive to on the project. They're loaded in sequence, so it's an on-type delivery process and solution. Again, it's all pre-prepared, so when it shows up on site, you're really addressing the on-time part of it. It's speed and efficiency is the key sort of focus. This here is the B1 layer going down. And then it moves to the B2, T2 type layers. And I don't know, I mean, you can look at the photographs. I think they're fairly representative of, there's a distinct lack of people moving around on that structure. If that was a traditional rebar mat, you would see, well, on the example which was done traditionally, there was 10 iron workers moving around there for over 2 weeks. This was all put together in less than 4 days, including all the dowel assembly and thickenings that went in as well. And it's also adaptable in the sense that, you know, there was openings or there was penetrations that weren't identified through the initial modeling, and there was some change to the footprints, all of which you can address even though it is pre-assembled off-site. This is an example of another structure we did, which was sort of like 4 large grade beams. The 2 on the left were done in a traditional format. The 2 on the right, again, you'll see in a time-lapse example. So in this example, there was about 84 tons collectively between the 2 beams on the right, and they were placed start to finish in 7 hours with a crew of 4 teammates. And that was done on, as you can see, which was probably the wettest day of December when they put this in. So again, you can see kind of the benefit of time and efficiency. So to talk a little bit about the process more in terms of the collaboration benefits, I'm gonna touch along a few of the administration benefits and things that we're trying to promote as well as recognizing, and then Lyall is going to talk a little bit about the actual on-site benefits. But as you can see, a lot of the process is originated around a model versus traditional drawing. And what the models bring today is, you know, there's a lot of viewing capability within the models today outside of the model software. You know, Tekla or Revit, you know, that's probably a lot of complexity. But if you're just a user like we are, you can move quickly into tools like Trimble Connect, which gives a lot of collaboration opportunity across the project. And that's what we're focusing on, you know. We recognized early the benefits of the end product, which is the time savings on site and the benefit. But there's also huge benefits on the front end, which is in the submittal process, the collaboration between the engineering, the architecture, the MEP, and working within that model in the confine of the viewer, whether that's Trimble or whatever that viewer may be. But a lot of that question-answer process is answered within this sort of, this technology today. You know, we can bring a very capable solution, but we can bring it to a lot of people very quickly, and we can get a lot of people around a virtual table very quickly, and we can move things along at the front end. I mean, I'm sure a lot of you are familiar with the Rebar submittal process, which takes weeks, if not months. And that's time which really nobody can afford. And again, you know, as a gentleman from SECO said, time is everything with owners, with developers, with our industry in general. And anything we can do to move that along is beneficial to all of us. So something, we're not fully recognized yet on this, but it's something where we see huge benefits, and the more people, like the organization itself, Pro is touching, and people like Kerry and CKC have recognized this, and we're trying to sort of elevate that into the market where and when possible. So again, like I say, the collaboration around the process is hugely beneficial. The modeling, the 3D modeling using the viewers as opposed to the traditional 2D. The sharing, it's live, it's virtual. We can eliminate a lot of that RFI process, and in doing that, we can minimize a lot of that change order, which is a cost component of our industry today. And again, it helps all the way through to the end results, which we shared a little bit, and which Lyall can sort of highlight now. So, Lyall, over to you.
Thanks, Eugene. I want to start by saying that the first slide, I think it said that I've been doing this for 44 years. I wish it was an exaggeration, but that's about right. And my dad was an iron worker, and he had an iron working business. And it used to be my summer job when I was in high school. So when I look at this and the way we do rebar today, it's really, the way we're doing it today traditionally, it hasn't really changed that much since the 44 years that I've been in this business. We've made great strides in safety, especially the last 10 years. We're a lot safer than we used to be, and we're really proud of that. But as far as improving the processes, the speed, the efficiency, we've got a long way to go. And of course, we believe that safety and production can both happen at the same time. And this is a process that allows us to do that. We're excited. One of the things that's most exciting is on these jobs, we have about 10 of them under our belt now, including maybe a couple that haven't started yet. If you talk to the iron workers on the job about how was your day, well, it's an easy day for an iron worker on a job site now, because they're really just managing a pick set operation. Instead of, thinking about it, a bundle of rebar comes off of a truck, gets loaded, dropped somewhere, gets broke open, the bars get packed, laid down, tied, set, spaced, tied, and all of those operations take place. So there's a lot of inefficiency in all of that handling at the job site. And it also requires a lot of people on a job site to do it. Now, there's still work to be done, but it's done in a controlled environment, in a shop, with overhead hoisting, which takes a lot of the manual labor away, should actually improve our safety results. I'm sure it will. And an iron worker, instead of having to commute to a job site, which he doesn't even know if he's going to the same job every day, he might have to count for hours in his daily schedule to get to a job, can go to one location and work in a shop where he can do this process in a controlled environment, in a safe environment where the elements aren't getting to him, where he doesn't have to break his back because there's a crane there. He has constant crane support, and his life is a lot easier. We did a job in Boise, and we talked with Kerry and his group and showed him about that. And I know the first day our iron workers did this on the job site, We said, come and join us after the job. We're going to take you out to dinner. And they showed up refreshed and happy and like not typically an iron worker at the end of the day. And they said they just can't believe the difference that it is in their life to be able to do this. Now, on the front end, we had iron workers in the shop. They're doing a lot of the labor to get ready for that. But it goes so quickly and so smoothly on the job site that it's very impressive to watch. So the results that we saw on this job, we've seen on multiple other jobs as well. It produces something that is a lot more predictable, easy to schedule. Crane time is something that can be scheduled. Instead of using a lot of crane time, hit and miss over a long schedule, we require a short, intense use of crane to just pick set, pick set, pick set. So about 75% less time on a job site. We still have time on the front end, but because of that time is on the front end, it really makes the collaboration process important. Because obviously if we're shipping panels to a job site that are pre-made, we have to make sure they're going to work when they get to the job site. So we got to understand and collaborate on what's the formwork guy doing, what's the MEP guy doing, how are we going to work around this? And there are things that change, and this can be modified to some extent, but the vast majority of it, we want to capitalize on the efficiencies and the collaboration that takes place up front. So we need a little bit more lead time, not a lot, a little bit more lead time. The main thing is getting involved with people who want to collaborate, right? Who want to be able to kick the process off earlier, get us involved in a model earlier, be able to benefit from the collaboration processes that Eugene was talking about. And if we can do that, if rebar and concrete are on the critical path, a lot of time savings on the critical path. So we think that a lot of owners will get excited about this. We're hoping more contractors will get excited about this because I think for the first time in my career, I'm seeing something really different than what we've been doing before. So we're going to be safer, more productive. And I think it hits on the heart of what Pro is all about. We're going to get there through collaboration. If there isn't any collaboration up front, it makes this process much more difficult because we need to make sure everybody's involved so that we get everything dialed in and when we set the panels on the job. So I don't think I've hit on everything, but again, I think this is exciting for us, and I think the efficiency and the collaboration that Pro is all about, this is a good fit. So that's it.